Hello, welcome to this lesson. In this lesson, we will solve a forward difference recurrence relation of trig functions. Okay, so in this lesson, we'll solve two examples. Okay, I'll solve one of them with you. Then you can pause the video, then you try your hand on the other question. Let's get started. So there's a nice question here. We are to evaluate the sum as r starting from 0 up to n of sine omega, and sum as r starting from 0 up to n of cos omega r, using the forward difference recurrence relation. So just like the differentiation in calculus, is whenever you are differentiating a sine function, your result will be a cosine function. At the same time, whenever you are differentiating a cosine function, your result will be a sine function. Okay, so let's begin with the sine of the sum of omega r, sine of omega r, as r starting from 0 up to n. Okay, so for sine omega r, we need to choose a cosine function. Okay, so we choose y of x. Okay, we choose y of x, which is equal to cos omega x on a, where a is any arbitrary constant. Okay, so the forward difference of cos omega x on a is given by this. Okay, so you just replace x by what? X plus 1. Okay, and you realize that this is of the form cos a plus b minus cos a minus b, where a plus b is what we have here, that's omega x plus omega plus a, and a minus b is what? Omega x plus a. Okay, but we want to simplify the right hand side, so we need to apply the trigonometric ratios. Okay, so now from trigonometry we know that cos a plus b is given by cos b minus sine a sine b, as seen in equation 1. Then cos a minus b is also given by equation 2. Okay, and you realize that the equation is of the form what? Cos a plus b minus cos a minus b. On this note, we subtract equation 2 from equation 1, and when we do that, the left hand side will be cos a plus b minus cos a minus b, and the right hand side will be cos a cos b minus cos a cos b, which is what? 0. Then minus sine a sine b minus another what? Sine a sine b, which gives us what? Negative 2 sine a sine b. Okay, so we solve for a and b simultaneously. Okay, you realize I see this a plus b is just like omega x when you compare omega x plus omega plus a, as seen in equation 3. Then a minus b is just omega x plus a. Okay, now we solve for a and b. So solving for a and b, solving for a and b we add the two equations. Okay, so adding equation 3 to equation 4, that will be a plus a, which is 2a. Then b plus minus b gives you 0. Then omega x plus omega x give you 2 omega x. Then a plus a gives you 2a, then plus omega. Then you divide through by 2, we obtain this for a. At the same time, also subtract equation 4 from equation 3 to obtain the value of b, and that will be what? B, a minus a gives you 0. Then b minus negative b gives you what? 2b. Then omega x minus omega x gives you 0. Omega minus 0 give you omega, that's what we have here. Then a minus a give you 0, so we get what? 2b 2b equals to what? Omega. Then when we divide 2 by 2, we get b equals to omega on 2. Now the forward difference, okay, of cos omega x plus a is now what? Negative 2 sine a sine b, where a is what we have here, and our b is what? Omega on 2. We are looking for sine omega r, the sum of sine omega r as r starting from 0 up to n. So we can find that one here. So we need to make it the subject. And how do we do that? We need to divide 2 by negative 2 sine omega on 2. And when we do that, when divide 2 by sine omega 2 on 2, we obtain this equation. Okay, we obtain this equation, okay, where negative 2 sine omega on 2 is any constant. Okay, so you can bring you find the sum on both sides. So when finding the sum, you can bring this out of the sigma notation or the summation sign. Okay, now from a definition, or from a theorem that we learned in our previous lesson, the right hand side, that is this term, okay, is just like this. Okay, you can refer to our previous lessons for that. Okay, so we are looking for the sum of sine omega r, so we need to find a way to eliminate these two terms, that's omega on 2 plus a. So how do we do that? Then we have to what? Set a to what? Negative omega on 2, so that when we replace our negative omega on 2, these two terms what? Vanishes. Okay, so we set a to be negative omega on 2, then we substitute it into our equation. When we do that, we get sum of sine omega r as r starting from 0 up to n. Okay, and the right hand side also becomes this, because this omega n, that's what we have here, plus omega plus a, but our a is what? Negative omega on 2, then cos a, that's cos negative omega on 2. But don't forget, cos is an even function. Okay, so let's choose a function f of x. This function f of x is said to be even if f of x is the same as f of negative x. When we say a function is odd, then it means that f of negative x is the same as negative f of x. Okay, so now let's just choose cos 45 degrees. Cos 45 degrees is root 2 on 2. Then sine, sorry, we are dealing with cos. Okay, cos negative 45 degrees is also root 2 on 2. Okay, it means that if we choose our f of x to be cos x, then cos, the x is what? 45, right? So cos 45, or f of 45, is the same as f of negative 45, okay, which is root 2 on 2. This means that cos of negative omega on 2 is just the same as cos omega on 2. Okay, so when you simplify this term to, you see omega minus omega on 2 is just omega on 2, and this term is just omega n. So we factorized omega out. When we do that, we obtain this, then that. Okay, you can multiply through by negative 1, or multiply through by the negative sign. Okay, and when we do that, we get you see, this will be negative negative, that will be what? Positive cos omega on 2 minus cos of omega into bracket n minus half, n plus half, all brackets closed, then divide by 2 sine omega on 2. So you can pause this video and try your hand on the other question, which is cos omega r as r starting from 0 up to n. Okay, so let's solve this question. Okay, so solving for cos omega r, the sum of cos omega r, as I was starting from 0 up to n, we choose a sine function, okay, that's y of n. This should be y of x, okay, y of x, such that our y of x is given by sine omega x plus a. Okay, so we find the forward difference. So the forward difference, you just replace this x by x plus 1. Okay, so the forward difference is given by this, and we realize that the right hand side of this equation, okay, is of this form: sine a plus b minus sine a minus b. Okay, so we try to simplify this, the right hand side, okay, of the forward difference. Okay, so we apply the trigonometric identities. Okay, so from trigonometry, our sine of a plus b is given by equation 1. Sine of a minus b is also given by equation 2. Now we are looking for sine a plus b minus sine a minus b, so we subtract equation 2 from equation 1, and when we do that, you see that will be sine a cos b minus sine a cos b. That will give us 0. Then cos a sine b minus cos a sine b is the same as cos a sine b plus cos a sine b, which is 2 cos a sine b, 2 cos a sine b. Okay, now our a plus b is what? This as given in equation 3, and we also have equation 4. So you solve equation 3 and 4 simultaneously. So when you solve equation 3 and 4 simultaneously, you will get your a to be this, that's omega x plus omega on 2 plus a. Then you get your b to be omega on 2. Okay, so now we know that our forward difference of sine omega x on a is just like 2 cos a sine b, but we know our a to be what? Omega x, that's a, okay, plus omega on 2 plus a, and our b is what? Omega on 2. We are looking for the sum of cos omega r, as I was starting from 0 up to n. So we make cos omega x plus omega 2 on a the subject. And how do we do that? We need to divide through by these two sine omega on 2. Okay, and when we do that, we obtain this equation. Okay, then we find the sum on both sides of the equation. When you do that, we get this. Okay, and the right hand side, that's the summation of the forward difference of sine omega r plus a for any r starting from 0 up to n. This term, okay, is given by this. Okay, so we try to, on the other side of the equation, that's the left hand side, we want to eliminate these two terms. And how do we do that? We need to set this a to negative omega on 2. And when we do that, we get cos omega r plus omega on 2 minus omega on 2, which is cos omega r. Then on the other side of the equal sign, that will be sine omega n plus omega minus omega on 2. But omega minus omega on 2 is just omega on 2. Okay, so that will be omega n plus omega on 2. Then this term is just sine negative omega on 2. But don't forget, sine is an odd function. Okay, you can test that. So let's choose 45. Sine 45 is root 2 on 2. Yeah, positive root 2 on 2. And sine minus 45 is minus root 2 on 2. This means that sine minus 45 is the same as minus out of sine 45. Okay, so sine negative omega on 2 is minus sine omega on 2, but already there is a minus sign here, so this minus sign changes to what? Positive. Okay, so here we factorize omega out, and when you simplify this, you get this as your final result. Thank you.